18, reach 18 student. So as we, okay, I want to clarify with our lecturer, others, because as you know, we're going to have a test, isn't it? Test 1, right? So test 1 will be happen on, wait, I double check. 23. So I want to ask them whether you are including or not. So I copy and put it in your WhatsApp group. Wait, so that is information that you need to know. Maybe I will put also on your test too. So because we are already late, that's why I ask all of you to watch the video I provided in the e-learning. So I guess our e-learning I provided on the numbering system and so on. In your module 2, I hope that I can cover as much as I can in our module 2, because it is mostly about 120 something pages of slide. So it's very, it's too many. That's why I asked you to check first and watch the video. And all the video also not only cover your module 2. When you are dealing with module 3, you're going to also see that, okay, you're going to have also link on your numbering system, because we are going to learn assembly language. So under assembly language that you're going to know, it is more on machine programming. So machine programming is one of the programming that need to know by computer. So computer normally are doing only know binary 1010. So that's why you need to learn on numbering system. So without any further delay, I'm going to start. Wait, I check your attendance first. 19 over 21. Okay. So I'm going to start sharing my the slide. Basically, my Perdana student already cover module 3 today, and tomorrow we're going to start lab 1. So any question in the middle of my class, you can just interrupt me and stop me. Okay, this is our module 2. I'm going to speed up. Let me check whether I already start recording or not, because it's very important for you to have recording session so that you can refer it back again, especially when you have like tests, quiz and final exam. Okay, if you can see over here, this is just objective why you need to learn what you're going to get in our module 2. So mostly it is touching on numbering system, whether it is a radix system and also a floating point. Later on you will see what is radix system, what is a floating point, and etc. So this 2.1, 2.2, 2.3, 2.4, 5, and lastly the summary is the one that you're going to cover, like fixed number, integer representation, arithmetic, floating number, and arithmetic. So you have to basically you have fixed number, which is called also as integer, and you have floating point, which is your fraction, nombor perpuluhan, and this one is nombor bulat. So first of all, what you need to know is on the arithmetic and logic unit. So at LU, you know already this is on the computing. We already learned in our module 1. So why you need to learn all of this? So maybe you are wondering how negative number are represented. Especially in the computer, right? Like computer language, how the number is represent. What is largest number? What is the largest number that computer can read or can be represented in your computer world? What happen if an operation create a number bigger than can represent? So what is the meaning? Later on you will see what is fraction and real number, apa beza fraction and real number, and what the mystery is, how does your hardware, which is your computer, really do the multiplication and divide number. So how your computer are processing all the numberings and do like adding, subtracting, and so on, right? So we begin our examination. This one is more on that like theory, how basically you come out with all the terms and etc. So you're going to see that there are two data type. First is fixed number, which is integer, and then floating point, yung punya nombor perpuluhan. So in your fixed number, you're going to learn on addition number, subtracting, multiplication, division. This one is just a mathematical system or standard you already learned in your primary school, which is on addition, subtractions. But I guess also currently our primary school also already cover multiplication and division, right? So since standard 1, you already learn on this all arithmetic. So why you cannot score this module 2? Basically because this is just a mathematics, which is you already learned. This one is like you refresh back your memory only, and this is also represent in a quite different way, which is because you are also dealing with the numbering radix, which is base binary, hexadecimal, octal, decimal, and etc. So that's why it's only that the difference. And also on the representation, you're going to look into unsigned number and signed number. And again, all of these fixed number you already learned in your digital logic. So if you think that you still didn't have strong background on numbering, please look back and watch back the video that I already shared in your e-learning. Sorry, there is someone want to join. Siapa yang lambat ni? Perseus J12. Wah, namanya.
Doctor.
Yes.
I'm actually in the class already, but I'm joining through my laptop right now.
Oh, okay.
So I'm not late.
Okay. So are you afraid that I am asking you question? It's okay. There are too many person over here that did not turn on and enable webcam. So I'm going to pick someone that did not enable their webcam to be asked any question. So shall I proceed? Okay, then you're going to learn on floating point. Dalam bahasa Melayu dia nombor perpuluhan. So in English is floating point. So there is also representation sama. It is similar basically in a fixed number, representation and arithmetic. But in floating point, you have the bonus. You only look into addition and multiplication. See, it's very simple, right? So we look first on ALU. What is basically happen? This one also you already covered that you have input output. You input any kind of numbering. Let's say I give example, and then you're going to get the output. Let's say you have 1 plus 1. So this one you key in and your system will process, which is your ALU, arithmetic and logic unit, will process whatever happened that you key in your instruction asking the to process. So it will give you the output later on, the result. So this is just overview what basically happened. So the main thing that we're going to look is on the numbering itself. So before we go to the arithmetic like the adding, subtraction, multiplication, we need to learn back on the numbering. See, it's like a primary school, right? Kita belajar nombor. Siapa lagi nak masuk ni? Sauraf Ahmad. Disappear. Suddenly disappear. Dia takut terkena soal tu. So he's afraid to join my class. Maybe he just realised he's late. Okay. Ni kan? Okay. So see, it is just like our primary school. Kita belajar nombor 1, 2, 3. So 1, 2, 3. This is a primary school. We learn mathematics. But basically only the different, we have the best. We have best 10, we have best 2, we have best 8. 2, 8, 10, 16. What else? This one is binary. And then we have octal. This one decimal. Hexadecimal. So this all is going to be your best number. So this one is your integer value. So you have the D multiples to your best, and you have I over here, your exponent or the power of what? So the value of I and D is this one. So where I start at 0 and increase from right to left. Right to left. Later on you will see what is basically this one. This is just numbering. I don't know what happened if you didn't memorize it. So this one also you already learned in your digital logic. This one nibbles represent for what, 1 bytes represent 1 byte represent how many bits, and so on. So you already learned all of this. This is just a recap if you look over here. So no need to touch much because this one you already learned several times, not only one time. So this one is like unsigned extension. So extension, a number representations to a large number of bits. So you have, let's say, this one 8 bits to the 16 bit. So you just extend from 8 bit. How to calculate? 1, 2, 3, 4, 5, 6, 7, 8. So 8 bit. So it's starting over here from 0, 1, 2, 3, 4, 5, 6, 7. So this one, ini yang, this one is the one that mentioned over here, where I start at 0, increase from right to left. So this one you can see, you increase 0, 1 from left to your right. From right to the left. From right to your left. So that's why it's increasing. So this is the value of your I over here. So you can see over here, this is your eyes. So I give you example. Let's say you have 2 times 10. This is your best 10 decimal. So let's say you have your I equal to, I give you 2. So how are you going to define? This one is mathematic. So you have, let's say like this. You put this one because this is sa. Is it dalam English I tak tahu. Sa, ratus, ribu, something like that. So you have this one, the digit 2. And then you put 0, 0 all in front, right? So this one is to the, sorry, how to erase. Okay. This one is 10 to the power of 0. This one is 10 to the power of 1. This one is 10 to the power of 2. And moving to your left. So over here, 10 to the power of 0. Any number power of 0, it will be 1. So 2 over here will be times with in front over here, this one. So 2 times to the power of 0, let's say. This one as I give you example. So you get 2 times 1 equal to 2. So if let's say you have over here any number, any kind of number, I give you example. Let's say your number is 0, 1, 2. So 10 to the power of 1, 10 to the power of 0, 10 to the power of 2, and etc. So over here you will get 1 times 10 to the power of 1, you will get 10. So you get 10, you will plus 2 times 10 to the power of 0, you will get 2. So equal, you will get 12. That's why this is 12 in decimal. So maybe you didn't see what else, maybe in binary. Okay, I give you example in binary 1010. Maybe I have 101. So this is base 2. So as I mentioned, I'm going to put like this 101 to the power of 0 to the power of 1 to the power of 2. And it will increase, right? So over here, this is my 1. I will multiple with this one. My 0 will multiple. This one is going to multiple. So between of these, I'm going to plus. So I'm going to get the decimal value. So 1 multiple to 1, you will get 1. 0 multiple to any number will get 0. 1 multiple to the power of 2, you get 4. So you get over here 4. 4 plus 0 plus 1, you will get 5. So means that 101, you will be getting 5 decimal value. So this one is just converting. I already share with you also on the video. So I hope that you watch it already. And inside number also, I already share you and you already learn in digital logic on positive and negative. So, because this one also you can see, and I share you the video already. Let me call, siapa ni? Emran Shovo.
Yes, ma'am.
What is the digit that represent positive number?
Integer.
What?
Integer.
Huh? Positive number.
Sorry.
What is number that represent positive?
All from 1 to 1, 2, 3, 4, 5, 6, all are positive number.
No, I said okay. You have the over here, right? You have the numbering system, which is
Okay.
sign extension. How to represent whether it is positive or negative number in the binary? What is the number that represent positive? What is number that represent negative?
Sorry, doctor, I forgot.
Forgot. Okay, we ask another person. Dia ada webcam tapi mana ni? Kenapa nombor tak keluar? Nazatul. Orangnya tak ada.
Oh,
Tiba-tiba muncul.
saya tak tahu. Sorry. 0.
Okay, 0 is positive. Congratulations, it's correct. Nafi Ahmad, what is number that represent negative?
1 in the sign bit.
Yes, in the sign bit is 1. So supposedly you can see over here, I already share with you also their notes. You can see if you have sign number, the numbers that represent positive will be 0 and negative will be 1. So over here you have 2. 2, normally it's not going to put negative positive in front, but it is positive number. So in front of it at your MSB, the most significant bits, which is on the left side, is going to be 0. And for negative number, it's going to be 1. So the rest of it, let's say you have 2. 2 is 1, 0 in binary. So over here, if let's say you are having add bit of number, if you having 2 value of your decimal, so in 8 bits, you're going to show it as 0 to 1. So the rest, you have another 6. You need to represent all with 0. 2, 4, 6, 8. So 2, 4, 8, 6. So this is the representation of sign number. And if you want to extend it, you're going to extend from 8 to 16, you just need to put 0 in front. And if let's say it negative number, so this one is negative, so you change it to the binary. Of course, it is 1, 0. This one is value of 2. But negative sign, you need to show it as 1. So all in front will be 1. How many? Okay. So it's going to be 1 in front. This as to show it is a negative number. This one also I already shared the video. I hope that you can try to refund back. And this also you already learned in digital logic. So yeah, this one is recap only. So if you still don't know, then it's going to be problem later on. So what else? Still under recap that you have unsigned and signed number. This one you already learned on first complement and second complements on your because basically I have meeting in Perdana UTM. Okay, so over here you can see that you have unsigned and signed number. So unsigned, this one is very easy. Only that later on you will see that fraction, whole number you have to do on the arithmetic, which is adding, subtractions, multiplying, and so on, right? So over here, in sign number, you have sign, magnitude, and complements. This is the one also you already learned, and I already share you with the video. If you have difficulty, please WhatsApp me. And if I didn't respond, please spam again, because I guess I having too many WhatsApp. Sometimes I already open, and then in the middle of I open, I try to reply. Then suddenly I have another things to do, so I forgot already. So please try to WhatsApp me until I reply, or maybe you can just WhatsApp me at your group, WhatsApp group, and inform that you did personally WhatsApp. So please respond and so on. So this one is unsigned number, still under recap. So I just try to be quick. So you can see over here, I forgot to close my door. Wait. Okay, over here you can see that you have MRS, million instruction per second, LSP, and MSP. So this one is the numbering of bit MISB word 41012. Only this one, but you need to having too many numbers 000 in front just to shows that this is positive number, something like that. But you need to know the range number. So this is the range number for 32 bit. You have 32 bit, you have 64 bits. So this is only the range for there is sorry, I got meeting, so people are not coming, so I was worried what happened. Okay, so you can see over here you have range of it. You have 0 until I don't want to mention it, 4294. Is it million or billion? This is the range number for 32 bit, and you might also have 64 later on. And you have the sign magnitude, which is the one that we know, which is positive and negative. This is still recap, and I give you already on the table, which is on the adding. 0 plus 0, you will get 0. 1 plus, I put it 0 first. 0 plus 1, you will get 1. 1 plus 1, 1 plus 0, you will get 1. 1 plus 1, you will get 2. Correct or not?
Yes, 10.
What? Yes. So this one, not 2, but this is 10. So this is sum. This is your sum, and over here there is no carry, but this one having a carry in front. And you have another one, 1 plus 1 plus 1, which is 1, 1. So you have sum 1, you have another carry 1. So if you convert it to decimal, you will get 2. If you convert it to decimal, you will get 3, isn't it? So 10 in binary is similar to 2 decimal. 1 in binary, you will get 3 in decimal. So easy peasy. So that's why, although you have too long, after you convert it, of course you are currently in a technology era. So you will just convert it using your scientific calculator. last time maybe we need to convert it manually. So you can convert it using your calculator to the binary, to the power of your binary. So you will get this number. From here, you will get 1 0 0 1 1 1 1 0 1 0 1 1 1 1. Okay, you add 0 1 2 3 4 5 6 7. Okay, so if you calculate, you have 7 bit. 4, 6, 7. So you need to put in front of it because this one is positive. That's why you need to put positive 0 and 0. So from here it's very easy, and you can see. Let me ask them to record the meetings. Okay, so you can see over here it's very easy just to convert it, and later on you will use the table I showed you previously. 1 plus 1 you will get 1 0. 0 will be the sum and 1 is the carry. And I already give also the table 1 plus 1 plus 1, you will get 1 1. So what will be your sum? Another one will be your carry. That's why you put like this. 1 plus 1, you will get 1 0. 0 1, you will get like this. This one is carry, this is sum. Until the rest you will get the answer like this. This one in front is 0, it will be positive. So that's why you easily to get this one. But sometimes if you didn't convert it into first complement, second complement, that's why you will get incorrect answer if you're just doing the sign number using the binary, normal binary. You will get overflow. So your result will be incorrect. So later on you will see this is the example that you will get incorrect answer. So how it happened? I'm not going to show you one by one. You can try to look into it back. The important part over here is we just want to show you using normal additions binary, you going to get error. That's why we're going to come up with solution. So the solution is the one that you want to learn, not the one that error. So error, this one is just adding a normal binary to binary without doing any conversions. This is only a normal sign magnitude. So over here, this one, you're going to see sometimes you will get error, which is overflow and so on. So we don't want this to happen. That's why there will be a solution. So the solution is we're going to come up with one complement, first complement, and second complement. So over here you can see there is first problem and second problem. Why sign magnitude we cannot use in additions our numbering. So you can try to look into it because this is still recap. Recap means it is not supposed to be in CoA, but this one is just to memorize your memory before you go to deep in numbering. So one complement or first complement also I already share you the video with at your e-learning. And how you going to get your first complement is very easy because you have 2-digit number only. You have 0, 1 only. So how you going to change it? You're going to change 0 to 1, 1 to be 0. This is how you're going to represent the first complement. Wait, my battery is slow. So over here, you can see that this is the one using first complement. How? You can see this one is at bit arithmetic, and you can have 9. 9, this one is positive number. So no need to change it to first complement. So what is going to be changed is only negative number. So your negative number over here, you have 23. Oh, I forgot already what is 23. So at 23, 3, so must be have 1 at the end. To the power of 0 to the power of 1. Let me. 1, 2, 4, 8, 16. So until 16, 16, 20, 1, and 1, isn't it? 16 plus 4, 20, 22, and then 23. So over here you have another one, 0. So this is 23 decimal. You convert it to binary, you will get 10111 in binary without negative sign. This is you only convert the magnitude. Magnitude is this one. Nilai dia, the value only. So the value of 23 decimal, you convert to binary, you will get 10111. Ni nombor kat atas ni apa benda ni? This is to the power of 0, to the power of 1, to the power of 2, to the power of 3, to the power of 4, and so on. So this one, using first complement. First complement macam mana? Daripada binary, from this binary number, you convert it. If it is 0, you convert it to 1. If it is 1, it's convert to 0. So from here you get 0, 0, 0, 1, 0. Simple, right? So this is the first complement for 23. So this one is 23 first complement, and you will see that this is negative number. So in front of it, because it is 8 bit, you have 1, 2, 3, 4, 5. 5 only. So you have another 3. 1, 2, 3. This one is represent this one is represent as negative, but in front of it also you need to put as 1 because this one is negative number. So that's why you will come out with this. Yang ini tak perlulah tunjuk. This one is you already know, right? This one is 9. 8 tambah 1. So that's why you get 9. So over here you just add, then you will get negative 14 decimal from here. So I guess until this one, how this one kalau you kira, you terus kira, you convert, you direct convert, you're not going to get minus 14. You need to revert it back to be binary. This one is still in first complement value, so you need to revert it back to be to be binary. So you tukar lah from 1 to 0, 1 1 1, and then this one is 0. So suppose this one is all 0 because this is magnitude only. So from here you get 8 plus 4 plus 2. So this one showing that it is 14 magnitude. So in science, the sign is negative. Easy, right? So anyone didn't understand? This is just a recap. So I hope that you can review back. If you don't understand, review back the video I provided because it's very detailed, and I give you several video which is CoA subject and also the digital logic subject. So there is example 5 also. This one is still under first complement. So I'm not going to touch it more. You try first at this example because this one is, you already done it before this. The difference only for first complement, if you have carry in front. First complement, if you have carry in front, you're not going to bring anything. The last carry is added to them. Sorry, this one you need to if you have the carry, you need to add back to here. This one is your first complement. For first complement, the carry is carry round and add to the sum. See this one. So you need to look into, because your second complement is different. So this one for first complement, if you have carry, you need to add it at back of the answer of your sum. Then you're going to get your answer. So that is the difference between first complement and second complement. After this, you're going to see your second complement. So for second complement, the step is quite easy also. So I'm going to show you the step. Where is the example? Okay, the step over here. Your your second complement is nothing more than first complement, which is your step. The first complement step is 0, you change to 1, 1, you change to 0. After that, you just increase or you add it with 1. So I give you an example. Let's say you have 7 decimal. In binary, you have, okay, this one is should be negative, but we ignore first. We just want to see the flow, the step, how you convert. So this one is decimal. Suppose in your binary, you will get 1, 1, 1, 2, 4, 3. Okay, so this is binary. So binary, you're going to convert to your first complement. So first complement, you will just change it from 0 to 1, 1 to 0. So this one is all 1. You're going to show it and convert it to be 0. This is first complement. For second complement, you need to add 1. So you will get 1, 0, 0 as your second complement for your 7. This one is, I just pick magnitude. So again, maybe I give you another example, 9. So you will have 1, 0, 0, 1. For your binary, you convert using your first complement, you will get 0, 1, 1, 0. This one is first complement. And for your second complement, you will add with 1. So you will get 1, 1, 1, 0 for your second complement. Supposedly, all these two's complement, your first complement, you're going to apply only on negative number. So in front, of course, you're going to put 1, 1, 1, 1. Okay. So this one, it shows you also the example. Please try to do it because this one is just a recap to recap your memorized memory. And you can see also sometimes you will going to have overflow. So if let's say overflow will be occur when you have two positive number add and the result negative. Two negative number you add, you get positive. So it is not possible to have overflow when you are using to complement if a positive and negative number are being added together. So you need to know that not possible. So it is not possible. That's why you are using two complements. Normally, if you use normal adding, you're going to have overflow, right? So this one, you can try look into it, which is a simple rule for detecting on overflow condition using second complements arithmetic. So you need to assume normally in your question, it will show you the bit, how many bits they are using, whether it is 8 bit, whether it is 16 bit, whether it is 4 bit. Normally it's going to be 4, 8, 16, 32.
It's 15 hours.
32 we're not going to look because it is too long. Maybe in final, yeah, but in test it's too long for test, I think so. So only 4, 8, 16 normally will be asking. And you can see over here, you have 23. If you just convert it, is like this, and this one is minus 9. So 9, I already show you. Is it here? Okay, this is the 9 for your second complement. So similar to this, and you add it. So you just add, you will get this answer, and you will see for second complement, your carry, you just ignore or you need to discharge. This is the different discharge carry for your second complement. So this is the different for second complement and first complement. So for your first complement, you need to add the carry around. But for your second complement, you just ignore. So you discharge the carry. So you will get the answer. So second complement, the carry is discharged. So this is the biggest differentiation between first complement and second complement. So is it okay? So this one, over here you can see that if the carry into the sign bit is different from the carry out of the sign bit, overflow has a cure. So you can see over here, when you add, let's say 1, 2, 6 plus 8, then you will get this answer, which is negative. Why is negative? Because there is a carry. 1 plus 1, you will get 1, 0. 1 will be a carry. So this one, normally it's not going to happen because you add positive number. How come you get your answer is negative number? So that's why you will assume it as overflow. And yeah, please try to do the review question. So there is a lot of question. And if you think that, okay, there is a different, because we already done with the Perdana class. So you can see over here, if it mention 2, it means that this is binary number. It's still not convert with a second complement. But if it did not show, you need to assume it's okay, it's already 2 complements. Something like that. Because this one, some of my students also feel like confused a little bit. But don't worry, this is just exercise in your notes, in the question of test, or maybe your quiz, or maybe your final exam. The question will be very detailed, so it will be easy for you to understand. Like maybe it said, okay, this is the binary number, or maybe this is first complement, this is second complement, so it will mention it clearly. So let's move. So any question? Any question on our recap class? This is our recap. So I hope that you have the strong understanding, because if you still remember last week, I already asked you to watch the video to strengthen your basic knowledge on numbering system, because all of that you already learned. So we just do a recap because we need that numbering system after this on our calculations, especially in our programming later on. So next we're going to look on arithmetic. See, we learn back what we already learned in our primary school. Addition, subtraction, multiplication, division. This is already covered in our primary school. So suppose you can score in module 2. I guess it's 100% all. Now we're going to look on the negation first before we look on the arithmetic. So under negation, what is negations? Which is on our second complement notation, the negations of integer can be formed like following rules. So you have 2 rules. First, take the Boolean complement of each bits of integer, including the sign bit, set each of 1 to 0 and 0 to 1. So this is the negation rules. Actually, what we already convert it from binary to your second complement is called as negations. So this one is first complement. After that, you add with 1, so it's going to be second complement. So negation is the process from binary to your second complement. So it's easy for you to remember. It's very easy to convert to first complement and second complement. There is no confuse at all. So this is the table for binary additions. I already show you also, and this is recap. And there is another, basically you have 1 plus 1 plus 1. So you have carry, 1 carry, and your sum will be 1 also. This is the table for binary addition. And you can try also look it. This one is your second complement representation adding, but you can also have this one is discharge. You need to see that you need to ignore because this is second complement. And same goes to here. So you need to see something which is overflow. So overflow that can occur whether or not there is a carry. So you can see over here you have 2 positive number. When you add, suddenly you have negative number. So you will know that, okay, this is overflow. When you have negative and negative number, you add and then you have this 1 over here, you will get the overflow. Because this one is positive. So suppose you will get negative number. Next, in subtractions, basically subtraction, when you are using second complement, you just using additions. So how you going to do it? You just convert it into second complements, then it's already in signs magnitude number. So let's say you have this 7, right? Negative 7. So negative 7, I already share you, tak nak lah yang ini juga. Okay, negative 2. Negative 2, you have this one is decimal. So if you convert to binary, you will get 1 0. This one in binary, you convert it to first complement, you get 1 0 1. And then you convert it to this one if first complement. Second complement, you add with 1, right? So you add 1, you get your second complement. This one is 1 0. So in front of it, you will put 1 because it is a negative. So then you will get like this one. So this is negative 2. So you just add. No need to subtract again. Although you will see that your equation will be 5 minus 2. So this one you will like assume 5 plus minus 2. Subtract that because over here you will get negative 2. You can try, and you can see also sometimes you can have the overflow. Please try to do all the exercise, and subtraction can be done. Okay, this one is the table for the subtraction. So you can see over here you have 0 minus 0, you will get 0. 0 minus 1, you will get 1. 1 minus 0, you will get 1. 1 minus 1, you will get 0. So how if let's say you have this one? So there is important part which is at this one. You need to borrow from beside of the left side. So over here you need to borrow 1 from the most significant bit. But before you borrow this, you need to come out with the answer first. If let's say I give you example 0 1 0 1, let's say. So you have like this. Let's say this one is minus or subtraction. You have 1 minus 0, you have 1. 0 minus 1. Don't borrow first. If you borrow first, let's say I give you example. You borrow and then you get 1. You will see, okay, this one is already become as 1. So 1 minus 1, you will get 0. So you will get this answer. So it's wrong. You see this one, 0 minus 0, 1 minus 1, you will get 0. No, this is not like this. You're going to do something like this. Apa soalan dia tadi? 1, 0, 1, 0. 1, 0. Macam ni kan? So you have this one. 1 minus 0, you will get 1. And 0 minus 1, you will borrow from this. But before you borrow, you will see 0 minus 1, you will follow this one first. 0 minus 1, you will get 1. And after that, after you already do this step, then you will borrow. Then you borrow like this. It becomes 0, So this one is fake. You already done this one, right? So then you will get the correct answer. So you need to do this step first, then you borrow. Okay? If you borrow first, you might be confused because you will get 1. Like, so after you get 1, you will say, okay, this one is 1 minus 1. So then you get answer like this. So it is wrong. So you need to follow this 0 minus 1. You will get 1. So please take note on this part. So if you look over here also, you have similar. You will have 1 minus 1, you will get 0, 0 minus 0, you will get 0, 1 minus 0, you will get 1, 0 minus 0, you will get 0. So everything is easy until you find 0 minus 1. You need to follow this first. You get answer as 1. Then you will borrow form beside. After that, you just ignore because you just borrow already and then you get already the answer. So you do this one, 0 minus 0, 0 minus 0, and 0 minus 0. So you get the correct answer. So any question while I'm moving to multiplication and divisions? So any question? I feel so cool, so I slow down my aircon fan. No question. So if no question, I guess you already understand on the adding and subtractions. On multiplication, so there is also table for multiplication. You can see over here, you have, if let's say you have 0 times 0, you will get 0. 0 times 1, you will get 0. 1 times 0, you will get 0. Of course, because any number is multiple with 0, you will get 0, right? So 1 multiple 1, you will get 1. And no carry or borrow bit. So this is the one that important. So previously on subtractions, you have these important notes that you need to remember. And in multiplication, you have also this one. So no carry or borrow. Okay, for multiplication. So let's remove that. We can see that we have multiplicants and multiplier. Okay, when we are going into the multiplication, for unsigned, it's very easy. But for signed, you need to apply different method. So under unsigned multiplication, you just multiple it using your normal mathematical formula. Only maybe, okay, this one because this is the binary form, that's why you need to follow the table. But basically it's very easy as long as, yeah, you already learn multiplications in your primary school, in your secondary school. This one is year 1, right? So in year 1 also, so more than 10 years you already do and done the multiplications in mathematics for unsigned number. Only the difference, you are playing around with the binary number. So binary number, you only need to remember this table in your multiplication. It's not hard at all. So you try to do it. 1 multiple 1, you get 1. 1 multiple 0. Sorry. Dah lupa dah multiplications. So 1 multiple 1, you get 1. And then 1 multiple 1, you get 1. 0 multiple 1, you will get 0. 1 multiple 1, we get 1. So this one finish. You do this multiple. So any number over here, you will get 0, 0, 0. Then this one finish. You multiple with this, you will get similar 1, 0, 1, 1. Same goes to here, you will get 1, 0, 1, 1. Then you will do the adding, isn't it? This one is just a mathematics. So kalau tak tahu ni, susah ni. So this one, 1 you bawa turun, you're going to bring it down. So 1 you will get 1. 1 plus 0 you will get 1. 0, 0 plus 0 plus 1 you will get 1. Mana? Okay. 1 plus 0 plus 1 plus 1 you will get, ini adding. 1 plus 1 plus 1 you will get 1, 1. So over here is 1 for your sum, and you will bring the carry over here 1. So 1 plus 1 plus 0 plus 0 plus 1 you will get 1, 0. So 0 over here. So this one tadi dah add carry. 0 over here you add another carry. Over here you will get 1 plus 1, 0, 1 also. That's why you will come up with this answer. So please try to do it. Don't just read without drawing something. You need to do until you understand. If you didn't do, then you are not fully understand. So please try to do it and apply it. So this one is multiplication for signed integer. So this will be your problem. So your problem is on multiplication signed integer. Later on you will see that although you are using a second complement or two's complement, you're going to have problem later on. So you're going to come up with the new method, which is first version of multiplication hardware. So this one is new methods because you have problem. So we check first what happened. Okay. So we already finished our unsigned multiplication. This one, we go back to primary school. So now we are in our university level, which is second complement. So second complement still, which is signed integer, we need to do the multiplication. So multiplication for signed integer, you can see the example. We go to straightly the example. This one is just for you to change for sign and also the second complement. So now let's say you have example. You need to multiply two complement binary number. So this one is your binary number. And you need to multiply it. So if you multiply it, you can see that you're going to get wrong number. Wrong number, not wrong answer. So what happened is you have -5. In binary, you will get 1, 0, 1. This one is in binary, 1, 0, 1. And then for first complement and second complement, you will get 1, 1, 0. So this one is your second complement, but because you are negative, so you need to put in front as 1. So this is -5. So -5, this one, this is your second complement. If you multiple it, you will get wrong answer. So this one is just to show you, you will get wrong answer. So regular multiplication clearly will give you incorrect result. So you need to have a solution. So multiplication algorithm for sign number, especially for negative number, the algorithm has the benefit something like this, which is you need to come up with solution. So this is why we come up with a new solution called as first version of multiplication hardware. Okay, you can see over here, this is basically your methods. You will have the flowchart. Of course, the flowchart will be making you confused because I don't like reading flowchart. I like number, but I don't like flowchart. So over here, you can see what happened. What is the flow that you need to do in multiply the sign number. So in sign number, you need to do like this. First of all, you need to check your multiplier 0 digit at the digit 0, whether the value is 0 or 1. If it's 0, it will direct to do second step. If it 1, it need to do the step 1A. So later on you will follow step 3, and then until this one repeat how many times. If you are multiplying 4-bit number, you will just repeat until 4 times. If you are multiple 8-bit, you're going to repeat 8 times only. But you need to see your bit or digit number. Let's say you have 1010 multiple with 10. So this one 4-bit. This one 2-bit. So you need to have 6-bit altogether. Later on you will see the example. So over here, you have the multiplicand, or you call as MC. You have the product as the result, and you have the multiplier or MP. So this is the binary form. So you're going to do on binary form, and you will do the step by step. So we direct show you the example in the form of the table. So first of all, you're going to have your MP. This is your MP. I just use the short name, okay? This is your MC. And of course, you don't know the product yet. So that's why the initial value, you didn't have any product. So you have 0, 0, 0. First of all, if you refer to the flowchart, let me bring the flowchart there. Okay, so over here, first of all, what you need to do is you need to check the initial form, initial value. These all the initial value. So this one is 0. Your product, your MC will be this one. So you need to convert it into binary. Then you need to do step number 1. Step number 1, you need to check the multiplier 0 bit. Where is the 0 bit? Is the most right value of your MP. This value 0 or 1. So first of all, you will see, okay, this value is 1. So you need to do step 1A. Your step number 1A is you need to add your multiplicants, your MC, with your product. So you add a 0, you add this one, so your answer will be similar. This add this one. Okay, so this is the first step. Alamak, nanti dulu. Okay, this is your first step. And then this one is you check the bit. Then after that, this is the first step. Okay, you get see your product over here equal to product plus your MP at above. So that's why you will get like this. Okay, so from here, you will see that you going to come out to your flowchart step number 2. Step number 2, shift your MC, this is your MC, to the left, 1 bit. So you can see, this is all 0, only this one. You're going to move it to the left. So shift it, you will get your answer 0, 1, 0, 0. Data shift already to the left. And after that, you're going to go to step number 3. Your step number 3 here, shift your multiplier to the right. So this one, this value, you're going to shift to the right. So you will get 0, 0, 0. In front over here, all 0, okay? So you will get 1. So this one is already to the right. So this will be to the right. So your answer will be like this. So let me check. Okay, this is the answer. So until here, so you will reach this part. Whether it's already repeat, it's already repeat 4 times or not, because you multiple 4 bit. So it's already repeat 4 or not? Not yet, because only 1 time. This is only 1 time you did. So you need to come up again, up. You need to repeat the process. Check. Okay, first of all, you going to do like this. Check the value of your MP, the rightmost, whether it is 1 or not. Yes, it's still 1. So you need to do the 1A. So 1A is P plus MC. So like this. P equal. Okay. So where is your P? Your P is this one. Where is your MC? This is your MC, not the initial, but you will pick the letters. So you will add. Okay, I try to add. I bring it here, okay? I will add it. Sorry, this one is 0, 1, 0. The rest is 0. So I will get my P, new P is 0, 1, 1, 0, 0, 0, 0, 0. Okay, and then I will go to second step. This is my second step. My second step, I need to move my MC to the left. So I will put 0, 0, 0, 0. And then this is going to move to the left, 1, 0, 0, 0. Okay, this is my new MC. And then go to the step number 3. Step number 3, I will shift my MP to the right. So my MP over here will move to the right. Or to the right, I will get 0, 0, 0, 0. So this is my new MP. This is my answer for all. So let me check. Okay, it is similar. So next, this is only second time. So you need to repeat it back. Repeat it back. What you need to check first, you need to check the value of your multiplier, the 0 bit. So over here it is 0. You will directly go to your second step. So there is no step number A1. So you will direct go to this one. So you will shift to the left. And this one you will get 0, 0, 0, 1, 0, 0, 0, 0. This one, right? Move to the left. Then step number 3, you move to the right. It's similar. It's similar because nothing happened. And again, you will do repeat again because it only third time. And still there is no 1A because your value of this one is 0. So you will direct go. And what is your answer? No need to repeat until end because it's going to be similar. Your MP is only 0. So this is the product. The final product you will get 0, 1, 1, 0. This is binary. If you convert it to decimal, you will get 6. 2 times 3, you will get 6. So this is the answer, correct? So I'm going to ask anyone in this class, are you having a problem? So any problem with the step? No, no problem, right? So if there is no problem, I'm going to give you a problem. I'm going to ask you a question. So there is a example over here. So I'm going to ask, so I will bring first the flowchart. Then you're going to see it. Where to put? Okay, over here. So I write the initial value first, 5 and 4. Where is it? 5 and 4. Okay. How I'm going to share with the G drive. Okay. Maybe over here. Okay, the initial value we have 5 times 4. Oh, sorry. So we have product which is 10. So we will take, let's say over here is our, I want it to finish as soon as possible. So I pick this one, 0, 0. But this one is very easy. 0, 0, 0, 1, 0, 0. This is the 4 in binary. And this is 5 in our binary, and our initial is going to be 0. So I'm going to pick someone. What is the answer? You need to fill in this part. Where is it? Okay, this one. You need to fill in this part. What is the answer? So I'm going to call Lisan. Lisan Shitki. Lisan Shitki. What is the answer for this? Are you there or not? Listen, Siki. If you are not here, I will remove you from my Gmeet. I can't use my Wi-Fi to join the class. Oops. I'm going to pick someone else while waiting for Lisan. If he's not come out also again, then I will just remove it from the class. So Nafi Ahmad. Nafi Ahmad,
Yes, doctor.
can you answer the question? What is the value here?
No operation.
Okay, there is no operation for 1A. Okay. So the value?
It's the same.
Yes, okay. It's going to be same. So now Nafi already answer, so I will remove this one.
Sorry.
What?
I don't know. Suddenly,
What again?
I suddenly. Sorry.
Okay, you will answer the second question.
Okay, I'll try.
So please answer what is the answer to this part.
Can you zoom the flowchart?
Okay.
Because we cannot see the flowchart. Just the flowchart.
Just yeah, I can't really see it clearly.
How to change my, I cannot select my flowchart. It's still there. How to remove my pen? Delete. Aduh. Okay. Sorry, I delete first. Okay, can you see now? So what is the answer? Over here. Listen.
Wait. If I'm not mistaken, 0, 0, 0. One. It's a 0. Sorry. 1, 0, 1, 0.
Okay, this is the correct answer. You need to shift your MC to the left 1 bit. So after that, you're going to shift MP to the right. So this one I will give the answer first. So we will have 0, 0, 1, 0. And then there is no operation also over here. You will get similar. Okay. So after that over here you will get 0, 0, 0, 1, 0, 1, 0, 0. And then to the right, 0, 0, 0, 1. Okay, I'm going to pick someone else. So over here, I want you to answer this one. Where is it? Okay, this part. So, Sauraf Ahmad. Where is Sauraf Ahmad?
Yes, doctor.
Okay, please answer this one.
Okay.
What is the answer?
I'm trying to make it just wait.
Okay. Can or not? Still didn't get the answer. Can you answer or not? Hello? Sauras? Hilang terus. Suruh jawab je. Sauras Ahmad. So who want to help him to answer? It's easy, right? So what is the answer?
We add 0, 0, 0, 1, 0, to 0, 0, 0. So it gives the same answer, I think.
Yeah, it's going to be because what is going to happen is we need to check first our value of here.
We have 1, yes.
This one is 1, so we have 1a step. So what the step is, P equal to P plus MC. So this one, this plus 0, you're going to get the same answer, right? So over here, then we're going to do our second step. Our second step, we're going to shift this 0, 0, 1, 0, 1, 0, 0, 0. And this one we will shift to the right. So over here there is no, because this one is 0. So supposedly if you will try to do it also can, but if let's say it's already no after that, then you can see that this is your final answer. So what is the answer is, this one is 1, 2, 4, 8, 16. So 16 plus 4 is equal to 20. So this is the answer for 5 times 4, you're going to get 20. So why you need to do this? Because you need to learn on the methods. Basically, where is it? Wait, I already zoomed it too much. So the problem is when you have signed number, you're going to have a problem by using second complement. So second complement, sometimes you will get incorrect result. So that's why you're going to use the first version of multiplication hardware. By using this method, you will get the answer. Where is it? Okay. By using the first version of hardly optimized multiplication hardware, you're going to get the correct answer for multiplication. So there is also this one is multiplier must be always in positive, which is you need to assume. I'm going to make it bigger. So this one, the multiplier, which is your MP, must be always in positive number. So if you have negative number, what is happen? Do an adjective inverse to the multiplicand, which is your MC, and the MP. If let's say you have multiplicands positive, your multiplier is negative, you need to change the negative value to your multiplier. Let's say this one is there is example 7 you multiply with minus 5, which is negative 5. You just change it to be negative 7. Basically it's similar because this one, the value magnitude of the value is similar, only the sign you change it and later on you will get similar answer. This is happen in multiplication, but for your adding and process something like that, you cannot just change like this. So this one, if you have negative and negative, of course you're going to have positive. This one I already show you, negative positive you get negative, positive positive you get positive, negative negative you get positive. So this is mathematical term only. So over here you can try also, but you need to pick the, let's say your MP, you need to your multiplier is negative. Let's say your multiplier is negative, you need to change it to be negative for your MC. So over here you will just do it similar things, only this one it is a negative, so you need to put negative in front. This is not second complement. This is not first complement. This is totally binary form. So only that you can see over here, this is all 1 because of this is negative 2. This is 1, 0 is 2 in decimal. So you can do the similar process and step, you're going to get the answer. Please try to do it. The similar things what we have done, we already looked into 2 example. This example and another one, this example. Please try to do it. You going to get the similar answer, and also this one. Please try to do it. The initial value already given, so you just need to apply it to the tables. Okay, this exercise you needed to use second complement multiplication. You just multiple it using second complement. Is the answer incorrect or correct? So you need to prove it and using the first complement. So which one giving you the correct answer? So this is just to prove that first version of highly operations multiplication hardware is the correct one. When you use second complement in multiplications, going to get error. So this is the part that you can write the second complement and also your multiplication for your first version. So please try to do it. Okay, now we're going to move to our division, and after that we're going to stop first because there is too much, I think so. I will push you and give you the example video for all these example, and you can also try it. Don't wait until last minute because you have only another like 2 weeks until your test, isn't it? So over here you can see we're going to cover our 2.4 floating point later on in Friday. I'm going to share with you the video first. So in our class, we're going to do the exercise and etc. And this one is only small part. So that's why later on next week, we're going to finish all and we will directly cover our chapter 3. So let we focus on the division first. Okay, on division, you can see over here, this is also primary school because this is division. Wait, I need to check my phone. Okay, the meeting is postponed to next week. Okay, so over here you can see that this is just your division mathematic process. You can see you have the divisor, you have dividends and quotients. And again, not forget the remainder. So please make sure that you still remember all of this. And this one is if you change it. Let's say I give you the example. You have 7 divide with 2. You get 3. You get 6. So this one will be your remainder. This one is your divisor. This one is your dividend. And this is your quotient, isn't it? So this is your quotient. So if you change it, you are going to get also something like this. Your quotient multiple with your divisor, which is over here 3 times 2 plus with 1. This is your remainder. You will get 7, isn't it? So this is in the divisions and this in the view on the multiplications. So basically similar. So this is just to show you the correlation or relationship between the components, just to show you and express. So over here, you have the very easy unsigned integers. Same goes to a very easy part on unsigned integer for your multiplication, but this one for your division. So on division, you can see similar. You have your mathematic, you can just divide 1 for 7, divide with 11. What is the answer? I forgot already. What is also your reminder over here? But you will change it. The difference is you need to show it and represent it in binary form. It is not too hard. You just change it to binary. So this one is 147 for binary. This one is 11 in binary. So over here, there is student asking me what is basically this one. How it's going to minus 0 minus 1, similar to what happened in the table. 0 minus 1, you will get 1. So over here, after you land, you will get 0 minus 1. So don't forget that you have this 0 minus 1. So you will have 1 over here. So this one, you will land over here from this. So you will get 1. First of all, you will see that this is 1 because you already learn or borrow. And this one is totally will be 0 because you already learn borrow it from beside. So you will get 1 over here and the rest is 0. So if let's say it's difficult for you because there is 2 times of borrow, you can do it step by step, then you will see. But the easier part is you convert it into decimal. What you will get? 1, 2, 4, 8, 16.
It's
So you
16
will
hours.
get 18. And this one is 1011. You will get 1, 2, 4, 8, 11. So 11. So you minus it, you will get 7 decimal. You convert it into binary, you will get 1, 1, 1. So that's why you will get, don't see this first, you get 1, 1, 1, 0, 0. So this is how you can minus it. But this one is unsigned. Suppose there is no problem at all. Then after that, you're going to bring down the beside value. Just similar what happened to your binary, your decimal divisions. So you can try to do it until below this one is no problem at all. The problem will come out with the sign. So this one is showing you a second complement. So second complement, you have also similar things. What happened? But there is a rules to follow. For second complement under divisions, you need to see there is 4 rules. So if let's say you have positive, divide with positive, you're going to get positive for your quotient and remainder also positive. It's easy, right? Because it's easy for you to remember positive. But then you have positive divide with negative. Your quotient must be negative. Your remainder must be positive. This is the rule that you need to assign by yourself while you are using second complements. So still, yeah, you need to remember it, right? Since this one is negative, divided into positive, your quotient will be negative and your remainder also need to be negative. So only different part, this is negative, so you change the place, then you're going to get different on quotient and remainder, the value signs. And lastly is negative and negative, you're going to get positive your quotient and your remainder will be negative. So negate the quotient if dividends and divisor were the opposite sign. So later on you will see what happened. This is the rule basically. So under here, binary division is restricted to 0 or 1. So thereby simplifying binary division. So you need to simplify it using 0, 1, 0. And this one is the new method that you're going to learn, this one, first versions. Because if you just apply second complements or two's complement, of course, similar to what happened to your multiplication, you're going to get sometimes the error and so on. So that's why you need to have the new methods. Basically similar, you need to have the flow chart. So the flow chart over here, you need to follow basically only that you have 2B and 2A over here. This is the MAC difference. And you are not going to look into the LSP, but you need to see the remainder, whether it is more than 0 or less than 0. So let we see the example. Sorry, I need to speed up because we already led 2 weeks, right? So I need to speed up. Normally, I will follow exactly the timetable, so there is no problem for interaction in class. Oh, to select again. Okay. So normally, I'm going to do with student the question. We're going to do it together, but yes, I hope that you understand why I need to speed up because we also need to know when we're going to have our quiz later on. So over here, we have several steps. So I'm not going to show this one because this one is, this is just a normal step. But the most important is the flow chart over here, and you're going to apply it in the table, similar what happened to your multiplication. Only the operation will be different. As long as you remember the flow chart, what is the step, then you can easily answer it. Okay, I proceed, okay? So over here, you can see that we have 7 divided with 2. It's cool. Okay, so we have 2 divide with 7, we divide with 2. So what is our answer? So normally we can divide it easily because it is a unsigned value. And if it is signed value, then you're going to have problem. That's why we need to learn on this method. So first of all, we need to subtract the division. So this is your divisor, register from the remainder. So you need to divide it from the remainder and place the result in the remainder register. So over here, you're going to put your answer here. what you need to do is you subtract, you tolak. So divisor start at the left half of divisor register. What is this? Okay. So over here you're going to divide it, subtract the divisor, and also your remainder. So over here you will see that first of all you will get 0, 0, 0 for your divisor, and also you have the remainder is 0, 1, 1, 1. Then what you need to do is you're going to do step number 1. Your remainder you subtract with your divisor r minus 1 minus divisor your d, r minus d, you're going to get 1, 1, 1 because this one is 0. Okay, we draw it here. And also our divisor, we need to start at left half of divisor register. What is the meaning by this? That all you will see. So this is the example. You can see that our d over here, we're going to change it into our second complement. Okay. So this is a second complement because over here we going to see this is basically 2. 2 over here. What is the meaning by this 2? That's why dividers start at the left half. Means that we're going to start here first and then we will put 0, 0 over here. Okay. Again, I repeat. So you have this one, your remainder is 7. 7, normally you will just put 1, 1, 1. This is binary, and then the rest you will put 0. So this one is easy, but for divisor there is a rules. Second or 2, in binary you will have 0, 1, which is 1, 0, right? So this is on our binary. Normally I said it's normally we're going to put 0, 0, 0, 0, 0, 0, right? But in our rules over here, we need to put this one to the back. This is 1 bit, so that it's supposed to be 0, 0 at here. So it will be 2 equal to 0, 0, 1, 0. This is the 2 in decimal, but this is binary. Then you need to add 0, 0, 0 at the right. If it is a multiplication, you're going to put in front, right? Of course, all the number you're going to put all in front. But there is a rules in divisions. You need to put it at the back because your divisor must start at left. Okay, so that's why you will get like this. So from here you can see that r minus d equal to r plus d minus. So from here d minus, you will see that this going to be your complements. You're going to pick all of these. You will do the second complement first. Your second complement, you will be 1, 1, 1, 1, 0, 1, 0. Sorry. 1, 1. Why? Because you just change. Sorry. Okay. So this one is first complement. Then second complement, you will add 0 plus 1, 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 1, 1, 1. So what happened? Am I too fast? So 1 plus 1, you will get 0, carry 1. 1 plus 1, you will get 0, carry 1. 1 plus 1, you will get 0, carry 1. 1 plus 1, you will get 0, carry 1. 1 plus 1, you will get 0, carry 1. 1 plus 0, you will get 1. Then the rest is 1, 1. So this is just second complement changing. What happened is, this is 2. This one is 2, but you need to follow the rules. You're going to put in on the left. Then after that, what happened? You need to change it using second complement. So from here, you first change to first complement. If 0, you're going to change is 1. If 0, going to change is 1, and etc. until you get your second complement, this one. So you will add. You're not going to, because this is subtract, basically this is a subtract, but later on you change it to be add. So that's why you will come out with this answer. So again, I remind all of you, don't just see. Let's say I give you this video right after this. Don't just watch it, but watch and then try to do it on your piece of paper until you get your answer, until you understand exactly what and why you get that one. So that is only step number 1. We have another step. After that, we need to check whether our reminder is 0, more than 0 or less than 0. So over here, we will do the B2. Why B2? So you can see over here, our B2 is 0, less than 0. So over here is basically there is no reminder at all. And we can see the next step is we're going to have if R less than 0, R equal to D plus R. So D need to be plus with your R. So this is your R value. So your Q later on, you will shift left and then you please you plus with 0. Later on you will see. So first of all, you're going to do D plus R. So D, you try to plus with your R value over here, what you're going to see later on your answer. So you just plus a normal additions. 0, 0, 0, 0, isn't it? And then you add with 1, 1, 1, 0, 0, 1, 1, 1. So you just add it, you will get 1, 1, 1, 0, 0, 1 plus 1, you will get 0, 1. 1 plus 1, you will get 0, 1. 1 plus 1, you will get 1, 1. So this is already obvious, so you just pick this part. So this is your answer over here. Then next step, you're going to shift left. So over here, you're going to shift left and you will add 0, which is this one, after you shift left. So next is, where is my flowchart? I delete. Okay. Oh, this one is next pages. After that, you're going to go to flow number 3, which is shift the register right 1 bit. So your register, you're going to move to right. This one. So that's why you will be getting this one. So you will follow again because you're not until 4 yet. You just having this one. So you will check again whether your answer, where is my flowchart? I need to refer back. You need to subtract. So you need to subtract your reminder with your divisor. So again, your divisor, you need this one, you need to change to second complement. So after you change this second complement, you will get this part. Maybe I will show you. Okay. 1 1 1 1 0 1 1 1. Then I will add 1. I will get 0 0 0 0 1 0 0 0. So I will add with my value over here. 0.
I think 1 1 1 after you add
Sorry.
yes 1 1 1.
Okay. Sorry. Okay, this is 1 1 1. So we add over here with this one. My answer is supposed to be 1. So, and I will add with this value. This one is the answer. See, I also already confused. So I will get 1 1 1. So that's why I will get this answer. I will put it here. So this is the step number 1. So I will get this one. So I check whether I have reminder or not. Of course, it is less than 0. Then it will do D plus R. So please try to add this one with this. Adding is not problem at all. And you will get, of course, it's very simple. You will get the answer. This one, adding this one. And you're going to shift again this Q. So your Q, you will move to your left. And your divisor, you will move to the right. So the divisor going to move to the right. So you're going to repeat until your step number, is it 5? You're going to repeat until this one is not similar. Okay, I show you one by one. So after this, you're going to shift until to the left, and then over here you're going to repeat the similar things that you're going to do something like this, R minus D, and then you will follow the same, which is you need to add, and you shift to the left, and this one you shift to the right, and then after that this one is basically continuous. Okay, so over here you will see that you're going to do step number 4, which is, if you go back to your flow chart, where is it, my flow chart? Okay, so this is my flow chart. You can see that if let's say you have 32 byte, you're going to repeat until 32 times for the multiplication. But for multiplication, but for your division, if you have 32, you're going to repeat until 33. And if let's say you are doing 4-bit like this, so you need to repeat until 5 steps. Is it okay? So this is already shown in the flow chart. So because you have using 4 bits, you need to repeat until 4 times. So then you just follow the flow chart. Please try to do it and draw it by yourself. And you're going to get the answer after that. This is the reminder. Your answer is your quotient. This is not the answer. This is your reminder. So this is reminder. This is your quotient, which is your answer. This one should be 3, isn't it? So what is the equation? Okay, 7 minus divided with 2. So okay, so 7 divided with 2, you get 3, and then reminder with 1. So please try to do it, and you can see that if reminder is less than 0, you're going to get 2b. If the reminder more than 0, then you will get and use the 2a. So please try to check whether this one is, maybe this one is negative number, which is -2. So you will see that you're going to do 2b. If the reminder is more than positive, which is more than 0, then you will do 2a. So it's basically similar with your multiplication, only the flow will be different. And you need to remember the flow chart. What is the process that going to be happen? So please try to do several times the table, because you have many exercise to try on. So you have several exercise to try, and please come up with the answer. So we already finished until that only. I'm not going to confuse you again today with the floating point, because floating point will be totally different. This is a having a fraction number. So from here, is there any question? Until here, is there any question? No question. So I guess you already understand all. And please try to do it. On Friday, I'm going to give you the floating point video. And next class, I'm going to ask you a question related to the exercise. So better if you cannot do the exercise or the example, please WhatsApp me and ask me directly. Is it okay? Okay. So by tomorrow, by next week, we need to finish our module 3. Also, we need to touch until lab 3, because I guess in our test 1, we need to cover until module 3. So if there is no more question, you can try to do your exercise and try to refer back what I already provide. And after this, I will direct share with you the module 3 and also the video. Okay, in your e-learning. So who still did not scan the QR code, please inform me. I'm going to share it now, the screen. So for the rest who already scanned the QR code, you can leave the Gmeet. Thank you for your participation and your attention.
Doctor, I'd asked you a question in private message, but you didn't reply. I just wanted to ask you, are all the softwares that we'll use in this course compatible with Mac OS?
There is a lot of students asking, you cannot direct install it in the Mac. what you need to do is you need to have the virtual box. What to do? You cannot have.
But in the new M1 Max, they don't allow virtualization by default.
Isn't it? Oh,
Yeah.
I don't know. But my version is still allowed the virtual box. So
So which software do we like? Visual Studio.
yeah, Visual Studio. Why? You want
Because
to find
that is available for Mac, but it has limited features in Mac.
yeah,
don't-
there is a limitation, of course. So that's why all other students also, some other lecturer are facing the same problem because students are using Mac sometimes, right?
Yeah.
So we don't have any solution yet until now.
So is it okay with Linux? Because I have a Linux laptop as well, but Windows I don't.
Oh, you did a partition. Why don't you just do partition with window rather than you have partition with?
No, actually, it was easier on the Intel Macs, but last year they switched to the other architecture, the M1 Max. It is very difficult to do that on them now natively. Like you have to like install parallels and all of that.
I never try installing at Linux. Do you try it installing it?
No, actually, I have another laptop like besides my MacBook, but that is a Linux machine, not a Windows one.
Oh,
So
but
I think.
that one you can just do partition, right?
Yeah, I mean that's why I was asking, because I want to just do all of this like at the beginning of the like in these weeks itself, not at the end. So in the test one, which is on April, which is on 23rd April, I guess, do we need to do with does it have anything to do with software and all of that, or just this module 2 and 3?
Because the question is not yet come out, but we going to cover until module 3. So suppose there will be something, but it's, I don't know whether you need to run or not the coding.
Oh.
But there is a simple coding which is under lab 1. What we're going to learn on lab 1, so we're going to apply. Maybe it's just a Q&A question.
Okay. Okay,
If
so test one
if the
can be
question,
managed like on Mac OS because
if the question is already come out, or maybe we already have the structure, then I will share any information with all of you.
yeah, because I want to like do all of this stuff after the test one on the 23rd. So
Yeah, because installing of also taking some time.
yeah, sometimes it fails, and it's a
Hmm.
very tedious, and the internet here is not good as well, so takes time to download big files. So that's why.
Yeah.
Okay, anyways, thank you.
Okay, thank you all. So if you don't have any question, you can left the Gym Meet now.
Thank you so much, Doctor.
Okay, thank you.
Thank you, doctor.
Okay, thank you.
Bye-bye, doctor. Have a nice day.
Okay, have a nice day too.
Okay, assalamu alaikum, doctor.
Salam.
Doctor, you have my name now, yeah?
Oh, I don't know, but basically if you check over here, it is 24/21, right?
Ines, yeah. I see my name.
The 21 is basically is more than is similar last week. So I don't know whether the system is still already update or not. But if you can scan, then it's okay.
Yeah, I can scan.
Okay.
You have my name. Can you check now?
It is on the system. Wait I check first. It here.
Yeah.
Okay. So your attendance already taken.
Then it's okay. Okay. Bye-bye, teacher. Have a nice day. Bye. Thank you.
Bye.
Bye.